Welcome back to Unit 7, Solutions, Acids, and Bases. We've spent a considerable amount of time in this unit focusing on solutions, but there are a couple types of solutions that we have not yet discussed in great detail. Those solution types are acids and bases. Acids and bases are chemical substances that release certain ions when dissolved in water. Acids and bases are extremely important compounds. But before we delve into those solutions, we'll want to explore a systematic approach to naming acids. Just like we discussed in Unit 4 when we talked about how to name various ionic and molecular compounds, acids have their own set of nomenclature, or naming rules. We can think of acids as falling into one of two categories: binary acids that do not contain an oxygen in their chemical formula, and oxyacids, those that do contain an oxygen in their chemical formula. These two categories of acids have different rules for naming them. When naming acids that do not contain an oxygen in the formula, binary acids, we take a systematic approach. The name of the acid will always start with hydro, followed by the root of the anion, and finally an IC at the end of the name. So some examples would be HF, which does not have an oxygen in it, so we name it hydro and then fill in the blank with the root of the anion. In this case, the root of fluoride is fluor, and then we attach an IC to the ending. So HF would be called hydrofluoric acid. HBr, hydrobromic acid, HI, hydroiodic acid, and HCN, hydrocyanic acid. If the acid does contain an oxygen in the formula, in other words, it's an oxyacid, then the ion present in the formula is going to be a polyatomic ion. So you'll need to identify the polyatomic anion that's found in the formula of the acid, because the name is going to be based on that polyatomic ion's name. If the polyatomic ion ends in ATE, then to name the acid, just change the ending of the polyatomic ion to IC, followed by the word acid. For example, H2SO4 contains oxygen in the anion, so we need to determine what the anion's name is. In this case, it's sulfate. Since an ending of ATE in the polyatomic anion would be changed to IC, the name of this acid, H2SO4, is sulfuric acid. Notice we did not put hydro at the beginning of the name of this particular acid. That's because we only use hydro when the acid does not contain an oxygen. If the anion contains an oxygen and the anion's name ends in ITE, then we name those acids by changing that ending of ITE to OUS. For example, H2SO3 would be called sulfurous acid since SO3 2- is the polyatomic ion sulfite, ending in ITE. You might have noticed that sulfate and sulfite become sulfuric and sulfurous acids. For certain polyatomic ions, we have to add back a syllable to name the acid. Phosphate is another example. It becomes phosphoric acid. But for other examples, like nitrate to nitric acid, we only have to add the ending. It takes some practice, but you'll get the hang of it. For now, just keep these naming rules in mind as we head back to the classroom where our students are investigating some properties of acids and bases.
Has anyone heard of the term indicator when talking about acids and bases?
Yeah, I remember we talked about that in one of my middle school science classes. I think it was a piece of paper that changed colors.
Good. It sounds like you got to work with litmus paper at some point. Do you remember what the purpose of litmus paper was?
I think it changed colors when it was an acid, or maybe it was a base. Maybe it was both. I don't remember exactly.
It's fine that you don't remember exactly because you're going to get to practice with it today. There are several types of indicators we can use to indicate whether or not a substance is an acid or a base, or neither. Litmus paper is just one of them. You can put a drop of a substance onto red litmus paper, and if its color changes to blue, you know the substance is a base. If there's no color change, you can try putting a drop of that same substance on blue litmus paper. And if it changes to red, you know you have an acid. There are also what we call natural indicators. and you're going to get a chance to create one and use it to test various household items today. This sounds a bit unusual, but red cabbage juice works as a natural indicator because its color will change depending on whether or not the substance it's immersed in is an acid or a base. What I'd like for you to do first is to create some red cabbage juice. To do that, you're going to cut up about 4 or 5 large pieces of red cabbage into smaller pieces and place them in one of the 1,000 milliliter beakers.
Like your audio comments. Oh, then cover it.
And then cover it with distilled water.
Oh, this is
You'll heat the solution until it boils for about 4 or 5 minutes, and then pour off the red cabbage juice and allow it to cool for 15 minutes. We'll be able to use the cabbage juice to predict whether or not these household items are acidic or basic or neither. So I want you to prepare your cabbage juice. After it's made, we'll test our items systematically. You'll test each item with the red litmus. If it doesn't change the paper's color, you'll then test it with the blue litmus. You'll need to write down your observations as you go, because after all the items have been tested with litmus, I want you to test each of them with the cabbage juice. Finally, you'll create a color key for the cabbage juice indicator based off the observations you made with the litmus. The items we'll test today are hand sanitizer, lemon juice, white vinegar, baking soda, and then shampoo and conditioner. You'll need to label each of the 6 cups with the different substances you're testing, then cover the bottom of the cup with each substance.
Conditioner?
For the baking soda, add enough distilled water to make a paste. You'll test each substance with the litmus paper.
No change.
When testing the solutions with the cabbage juice, you'll want to pour an amount of cabbage juice equal to the amount of the substance you have in the cup.
Ooh, baking soda.
Then you'll want to write down your observations in between each sample.
What?
That's baking soda.
Baking soda.
Yeah.
It looks like our students are already started, so now is a good time to take a break and let you begin this lab. Instructions and material lists can be found in the Chemistry Matters Toolkit. When you're done and you've both recorded and analyzed your results, I'll see you at the top of the next video to compare them with the results of our students.